Good afternoon, everyone. I'm Abhay from EDS Technologies. First of all, we thank you for taking your time out and joining today for our webinar, which we have titled as Develop, Optimize, and Virtually Validate Dynamic Behavior using Multibody Simulation Technology called Simpack. So before beginning the webinar, I would like to give a small introduction about our company, EDS Technologies. Next slide, please. EDS Technologies was incorporated in 1994 to focus on providing PLM solutions, implementation, and support. We are the largest technology solutions provider in India and also platinum partner to Dassault Systems. We have served more than 2,000 customers and operate in 10 locations across the country, with our headquarters being at Bangalore. We also have strategic partnerships with world leaders like EOS for additive manufacturing requirements, Human Solutions for ergonomic solutions, Technia for ensuring product data quality, Mac Technologies for military simulation and training solutions for aerospace and defense industry, and SRE for GIS requirements. We also have EDA. We also have a strategic partnership with Synopsys for our EDA solutions. We have a dedicated sales, support, marketing, and customer satisfaction teams to address our customers' business requirements and support requirements. The speaker for today's webinar is Mr. Anand Kumbhar. Next slide, please. Mr. Anand specializes in multi-body simulation with Simpack and finite element analysis with Abacus solutions. Both of these solutions are from Dassault Systems. He also provides technical support, training to customers, helping them leverage these tools effectively for their engineering needs. Currently, he is working in EDS Technologies as Senior Application Engineer. He has completed his post-graduation in Mechanical Engineering Design from Rajaram Bapu Institute of Technology, Maharashtra. So before handing it over to Anand, I would like to inform the audience that during the course of the presentation, if you have any questions or queries, we shall be taking up once the presentation is over. You can drop the queries in the question box or the chat box, where Mr. Anand will answer once the presentation is done. Over to you.
Yeah, thank you, Abhay. Okay, now let's begin with this webinar. Sorry. Okay, so this is the agenda for today's webinar. So first we will discuss the automotive industry trends and challenges. Then we will discuss the benefits of the Simula MBS Simpack solution. And okay, there are advanced vehicle dynamic MBS processes like handling scenario, okay, ride is there, drivability, durability, NVH real time. Okay, so we'll discuss all this, and then we'll see the Simpack competitive landscape. And okay, so conclusion is there last. Okay, now let's begin with the automotive industry trends and challenges. So first challenge is the complexity. So modern vehicles are mechatronic systems with continuously increasing complexity, and it's a huge technical development challenge to innovate and deliver an outstanding, exciting, and competitive vehicle product. Next is diversity. So there is a huge increasing amount of variants and potential different vehicle configurations. Okay, and this needs to be, these all variants and configurations needs to be managed and validated during the development process. Next is the necessity. So so market pressure, there is a market pressure on manufacturers to develop new and innovative vehicle products. So with a minimum physical prototypes, and also they want to develop it within a shorter development time and at minimized cost. Also, they want to develop it without causing any warranty issues. So these are the top means three challenges. So how can Simula Simpack help to master these challenges? So okay, so I will we will discuss this I will answer this question in later slides. Okay, so before moving for the benefits of the similar Simpack, so I will just introduce this, what is Simpack and what are the application areas of the Simpack. So Simpack, what is the multibody simulation, dynamic simulation? So it is an abstraction of the 3D mechatronic systems into rigid and flexible bodies, then joints and connections, then force elements, excitation sensors, etc. Okay, so if you see here, this one is the, okay, this is real system, and then we need to with the uh, for this real system, first we need to draw this. This is called as 2D topology. Okay, this is abstraction of the 3D mechatronic system or this real system. So here we can see these are the body chassis, this wheel, okay, this upper control arm, lower control arm, and it shows how these bodies are connected to each other. So this blue color, they are the joints. Okay, they represent the joints. These red colors, these are the force elements. Here we can see which force element is there. So with this 2D topology, we can understand how these bodies are connected to each other. Okay, and why this abstraction of 3D mechatronic system? Because in order to efficiently simulate and predict and optimize the nonlinear transient dynamic system loading, system loading, motion, and acoustic behavior. Okay, so now what is Simpack and what are its application areas? So Simpack is used to predict and optimize the motion and loading of any mechanical or mechatronic system that goes even up to acoustic range. Okay, so first application is automotive. So in automotive applications, we can do the handling, ride, NVH, durability. Okay, so we will discuss these scenarios in coming slides. Next is a complete combustion engine. Okay, so so it is a complex system and it has almost 100 moving parts, including flexible chain guides, then flexible crankshaft, flexible valve spring, then flexible camshaft, okay, etc. So there are a lot of details. Also hydraulics for hydraulic lash adjuster to keep the contact between the camshaft and valve springs. Next application is a railway vehicle. So Simpack is very strong in a railway vehicle. So it is the first application of the Simpack. And here in this railway vehicle, so we can do the derailment analysis. Then we can perform the comfort analysis. Also, we can calculate the critical speed of this railway for the safety purpose. Next is a floating offshore wind turbine. So here we can generate the aerodynamic and hydrodynamic forces which are coming on this turbine, okay, in Simpack, and we can analyze that. So next is the roller coaster. Okay, so this is any type of railway vehicle. Okay, so here we see the roller coaster, and we can check for the wheel rail contact here. Next application is land machinery. So here also it is often very important to bring in the overall hydraulics and control into that system. So here is this way, actually the part of benchmark, just running the vehicle at different speed, and it is also running over bump. Here we can see. So next is a general machinery. So this is any type of drive or drive line, drivetrain or drive line. Okay, so here we actually seeing the flexibility of the ring, which is taken into account. Okay, now we will go for the what are the benefits of Simulia MBS Simpack. So these are the benefits like versatility and efficiency, then solver robustness, result accuracy, okay, real-time capability, and process automation. So we will discuss this. I will explain this one by one, all benefits of the Simpack. So first is the versatility and efficiency. Okay, so it's mainly, what does it mean? What does efficiency mean? So it's mainly easy and efficient model setup, and it's about the simulation process standardization. Okay, and it is also related to the advanced MBS result assessment. And how is it achieved? So we can do the easy and efficient model setup of any MBS system with the help of the Simpack Pre. Okay, Simpack Pre is the state of the art advanced MBS user interface. So Simpack Pre, we can use it for the pre-processing. Then, and Simpack Wizard is there, which is a vertical application of specific processes. So here in Simpack Wizard, we will see, means we will get the standard templates, and then with the help of the standard templates, we can define the model and load cases. Okay, and also we can generate the scenario, and we can get the result for that particular scenario. And then for the result generation, there is Simpack Post for the post processing. So it is MBS optimized result analysis solution. And why is this important? Because it provides the option to do fast modeling turnaround times to obtain reliable result simulation results due to the process standardization, and it allows to do a fast result and KPI assessment. Okay, next benefit of Simpack is the solver robustness. So this is the unique benefit of Simpack. So what does it mean? So it's mainly challenging simulation scenarios are running reliably. Okay, so for example, if you see animation on the here on this right side, so it's a complete vehicle model which is running on a huge single bump, right? So here lift off and touchdown effect, which is a quite challenging simulation for the numerical point of view. Okay, from the numerical point of view, and so this is running very robust in Simpack. You can see. So this means that there is no time-consuming solver tuning is necessary, and also parameter studies are running reliably in Simpack. And how is this achieved? So Simpack, of course, that's the Simpack's unit means unique on long-term industrial proven MBS solver technology, which is implemented and available in Simpack. And of course, it is important this because this guarantees the simulation process reliability and also projectable results availability, which is essential for according simulation process. Next benefit of Simpack is the result accuracy. And what does it mean? So accuracy means proven result accuracy that goes up to acoustic range. So Simpack does not only deliver the accurate results in low frequency areas, for instance, for handling dynamic applications, but also accurate results up to the acoustics of the gearbox noise and other acoustic effects. So accuracy also means that it's possible to set up models with a unreached level of model detail. Okay. So for example, here in this example, you can see complete car. I don't know why it is not animation starting. Okay, you can see complete car models, complete truck models, and also a complete engine model containing a lot of detailed components. And due to Simpack solver capability, it's possible to get really very precise and accurate results for those kind of models. Okay, and how is this achieved? So there is important technology which is the Simpack flex body integration technology. So there are several options on how we can include the flexible body into Simpack. So for instance, on the right side you can see the different options, which is the Simpack MBS integrated reduced linear flexible body approach. Okay, which allows to include the for instance, or for example, flexible car bodies, okay, for any linear deformed component, so within the simulation model. And in addition, we have a very innovative and accurate new approach to consider MBS integrated reduced non-linear flexible bodies. So for instance, this might be used for components like twist beam suspension, right? So where there is a significant geometric non-linearity. And high-end solution for integrating flexible bodies is the MBS APM co-simulation, for instance, between Simpack and Abacus. So which provides fully non-linear result behavior. So for instance, if there is also plastic deformation in the simulation component, okay, so for plastic deformation, if you want to consider the plastic deformation, you can go for this MBS FEM co-simulation. So Simpack provides a lot of sophisticated and very well validated component models to be used in the system simulation models. Okay, you can see here on the right hand side, you can see the selection of those models which are necessary to set up for the system simulation. Okay, see, these are all standard elements. You can see bearing is there, tire is there, right? So suspension, spring is there, gears are there. So some standard modeling elements are available in Simpack. We can directly use those elements, which are very easy to use. Means minimum input is required for this. And last but not the least, Simpack solver technology. So Simpack's unique and long-term robust, long-term industry-proven MBA solver technology, which enables this unique result accuracy. Okay, and why is it important? So, of course, it's in order to ensure to trust in and rely on the simulation and somehow the prerequisite to replace or minimize the need for the physical prototypes with accurate simulation results. So next benefit of Simpack is the real-time capability. So this means that we can do an unreachable level of model details, enabling new simulation processes. And due to the fact that we have those detailed models also running in the real time, okay, we now can enable processes like real-time ride simulator as you can see here in this picture. So actually, what does it mean in general or simple language means that virtual world and real world, they are coupled together. So what does it mean in terms of process simplification? So being able to use the same model for offline and real-time application, this means there is no need for the real-time model simplification. So therefore, also there are no need for additional real-time model validation. And relying on only one model for all kind of application definitely it means huge process simplification. And how is this achieved? So it's again it's related to Simpack solver technology. Okay, and especially its unique real-time solver technology, which is developed in Simpack during the last several years together. And why is it important? Because see, of course, this approach enables significantly less simulation process effort, and it allows to do a faster and easier KPI assessment. Okay, and last but not least, Simpack benefit is the automatization capability. So this means Simpack provides a coding tools and processes, coding tools and processes to do an automatic execution of standard simulation processes, and also automatic assessment of standard product KPIs. Okay, so how is this achieved? So you can see here there is Simpack Wizard. Okay, one component of this approach is Simpack Wizard capability, which facilitates the standard processes, as you can see on the right side. You can see here standard templates are there, and from this standard templates means what predefined models are there. So from these predefined models, we can means directly build this full vehicle. Also, there are predefined load cases, right? So we can select the load case, or we can take the load case. We can combine these two, model and load case. So we will get here one scenario. Okay, for example, handling or something else you have taken. So you will get the scenario, and then you can directly run that, and you will get the results. Okay, and this will deliver the standardized results, and you can also automatically compare those standardized results. So it's based on intelligent assembly of model hierarchy levels. So you can see on the right side, the whole processes are based on template-based parameterized models, which can be grouped in models and submodels, and they are assembled automatically. Okay, you can see these are the component models. So from these predefined the components, these sub models are built. Okay, and from these all sub models, this main model is built. Okay, and then this is the analysis scenario. Okay, and last but not least, the Simpack provides the scripting capability for all kind of Simpack functionalities. So this starts with the model creation, okay, and goes through a solving the models and doing the parameter variations that goes up to, and that parameter variations up to an automatic result post processing. So what are the benefits? So it allows to minimize the manual simulation process effort, right? So we can directly take the standard templates, okay, and then we can build the full vehicle. So it reduces the human effort. So it delivers a reliable simulation process and results also, and therefore it's a faster and better product KPI assessment and optimization. Okay, so next, now I would like to come to the next part of this presentation, which is to give you some application examples regarding advanced automotive industry MBS processes. So first, I would like to start with the vehicle dynamics. Okay, so vehicles dynamics, and so within this vehicle dynamics, there are many relevant components and systems to be considered. So this starts, for instance, with the combustion engine, okay, or with or electric drive systems, and go through the engine and gearbox block unit. Okay, that includes the clutch, flywheel converter component. So it includes flexible gear drive and flexible drive lines. Of course, flexible elastic kinematic or kinematic suspension. Then steering system, and last but not least, flexible car body or subframes. So this means it's a single component and a detailed complete vehicle mechatronic system dynamic simulation. So typical workflows in the vehicle dynamics application areas. So I will explain in the next slide. So first is the handling. Okay, I will have to start with the workflow handling. Then, so this means it's the assessment of the lateral vehicle dynamics and according KPIs. Right. So typically, a vehicle should be easy to drive and easy to control at lateral dynamics stability limit. It should be also fun to drive. For instance, dynamic steering response and steering feeling should be convenient. So in order to achieve this, it's a complete vehicle simulation in terms of open loop maneuvers like a constant velocity cornering analysis scenario or fish hook analysis scenario, as well as closed loop maneuvers include uh, double lane change scenario, also constant radius cornering scenario. So next workflow in this vehicle dynamic processes is ride workflow. So what does it mean? It's related to vertical vehicle dynamics and according KPIs. Okay, so the target is convenient vehicle vertical oscillations behavior and the related occupant driving comfort perception. So in order to achieve this using the virtual simulations, for instance, hydropulse test rig, right? So simulations are used including deterministic excitations, then synthetic stochastic excitations, and measured road excitations and transfer path analysis. Okay, so we can do all these types of excitations by using this hydropulse test rig simulation. And another option is to drive the vehicle on a virtual road. And in order to achieve this, there are several options to do this. For instance, single obstacles. Okay. Then using synthetic stochastic road surfaces, also based on measured road surfaces. We can also include the measured road surfaces. So next workflow in this area is drivability. So drivability means the longitudinal dynamics and according KPIs. So the target typically should be there is a dynamic but same time convenient longitudinal acceleration and deceleration to be achieved. So how can this be assessed and optimized using simulation? So that's basically used in longitudinal dynamics, complete vehicle maneuvers. For instance, we can do the gas pedal tip in and tip out behavior simulation. Then idiot start, or it is also called as a rapid start, right? So idiot start is basically rev up the engine and drop the clutch. So that is extremely harsh simulation scenarios. So when you do that on your car, so you are going to excite everything that can vibrate. So you need a very robust solver to solve that, right? So then next you can investigate the gear shift behavior, or also braking behavior of the vehicle. So next workflow is the durability. So durability is related to the mechanical component reliability and according KPIs. So for instance, these are the dynamic loads and stresses, and fatigue and durability result derived from the dynamic loads. Okay, how to determine this in virtual simulation? So typically there are hydropulse simulation, then rough road simulations, or also driveline loads, okay, and oscillations. So which are input for the according dynamic loads. And also abuse or extreme events can be used in order to determine according loads. So for instance, maneuvers like pothole braking or even obstacle collision between the suspension components and obstacles might be simulation scenarios. So in this stress, see, we can get the stress result from the post processing. It is possible inside of Simpack, and we can provide that stress results as an input to the durability codes. So next workflow is the NVH. So NVH means mechanical structural noise and vibrations of the vehicle, and they are also according KPIs. So for instance, there is a resonance frequencies and amplitudes of forces and accelerations, and we can also determine surface velocities or assess the acoustic pressure. And how is this done? So it's basically doing the nonlinear powertrain and driveline effect analysis up to the acoustic range. Okay, for instance, by doing a complete vehicle driveline run-up simulation. So complete vehicle driveline run-up simulation. So it is a, what is this? So it is a diagnostic procedure used to assess the condition and performance of the vehicle's entire driveline system. So this test involves running the vehicle through various speeds and loads while monitoring the driveline components for any signs of issues. And then next, the simulation scenarios like gearbox whine and gearbox rattle. Okay, so gearbox whine means it's a high-pitched, smooth, continuous noise that often increases with the vehicle speed or engine RPM. And gearbox rattle, so it is a more irregular, metallic or chattering noise. Okay, last but not the least, related to vehicle dynamics workflow is the mechatronic system experience workflow. So this contains software in the loop, hardware in the loop, and main in the loop. Now, mechatronic experience relates to a convenient overall mechatronic system experience. So especially it's important to enable simulation-based development of advanced driver assistance system, for instance, for autonomous driving. So, and how can this be achieved? So there are several technologies like hardware in the loop, then software in the loop, or man in the loop simulation. Especially for the simulator applications, using Simpack's unique real-time capability, it's not only possible to do handling simulation, but also to establish new workflows related to the ride and drivability simulators, okay, which is a huge potential to eliminate, okay, to minimize or to eliminate the prototypes in the future. Okay, in order to summarize the vehicle dynamics workflow again, so this slide, I show that there are several workflows related to the vehicle dynamics, and it's important to note that almost all of them are also able to be performed in the real time, okay, due to the Simpack solver capability. And definitely handling then ride, drivability, and also mechatronics system experience workflows are possible to be executed in real time, and that's really a unique capability of Simpack. Okay, and therefore to summarize this part, Simpack somehow is the vehicle dynamics enterprise solution because only one model is suitable for all vehicle dynamics applications for all those kind of workflows which I have explained before. Okay, next is the Simpack competitive landscape. So how here I will explain means how Simpack is better than the its competitive products. Okay, or competitors like Adams is there, VL Motion is there, Recordine and Motion Solve. So you can see here. So these are the benefits or the strengths of the Simpack. Okay, and means all softwares, but Simpack is good at high frequency result accuracy, solver efficiency and stability, and cross application model compatibility. Okay, also it is strong or better at high end real time capability than other competitive tools or other competitors. Okay, so in this area which is highlighted here in yellow, Simpack is stronger than the other competitors. Okay, so as you might remember, in the beginning of this presentation, I asked the question, how can Simpack help to master the challenges? So regarding complexity, Simpack helps to cope with the increasing systems and system complexities because Simpack innovates and provides unique MBS simulation technologies. So in terms of diversity, so Simpack allows to efficiently simulate and assist the many variants. Okay, because Simpack contains sophisticated solutions for the MBS process standardization and automatization. And last but not the least, so using Simpack also facilitates the fast development times and at minimum cost because Simpack is the best available, fast, robust, and accurate MBS solver on the market. And okay, you might have seen the selected examples in this presentation. So Simpack has been chosen by many customers and industry and has proven that it is the right choice to help to master the according challenges.
So I would like to thank you Anand, for delivering a very informative webinar. I'm really confident that it was very helpful to our audience as well. I would like to also thank all the audience for taking their time out and joining us for this session. If you have any further queries related to the subject matter or any other simulation requirements, you can always connect with us. Our credentials and details are displayed on the screen right now. You can reach out to us anytime and we'll be happy to address your queries. Before ending this webinar, I would request the audience to also fill in their valuable feedback, which shall pop up once the webinar is closed. Please do keep an eye out for our upcoming seminars and webinars. You can follow us on our social media for the same. Thank you once again for joining us today. See you at the next session.
Yeah, thank you all for joining this, for attending this webinar.